Okay, in this video we will be solving quadratic functions by factoring. So what these questions will look like, it'll say find solutions, root, zeros, or x-intercepts. So we've learned how to find vertex, if it's pointed up or down, all that good stuff about a quadratic, and now we're going to solve for the x-intercept. So visualizing that, that's where a parabola touches the x-axis. Anytime it touches the x-axis, it's going to have a y-coordinate of 0 because you would go over a specific number and then you wouldn't go up or down, so it would be something comma 0, something comma 0. So as you can see, a parabola would either have two x-intercepts, it could have one x-intercept if the vertex fell on the x-axis, or it may not have any x-intercepts. This is the case that we will not look at in this video, but you will see that later on. Okay. So for this one, if I wanted to find the solutions, root, zeros, or x-intercepts, I would put 0 in for y first of all. And the problem is, you know this, that there's an x squared term and there's an x term. Therefore, we can't get x all by itself unless we complete the square. So if you have that scenario, you're going to try to factor it. First rule of factoring, see if there's a GCF. There's not. So you're going to try to factor that into two binomials. X squared, you could get that by doing x and x. Multiplies to be 6, adds to be 7. I can say that because the a is 1. So that would be 6 and 1. You'd have two positive signs. Check that. X times x is x squared. 6 times 1 is 6. And then that would be x plus 6x in the middle is 7x. So that did factor to those two. Now when you get there, what you're going to do is take each binomial and set it equal to 0 and solve for x. So here you'd get x equals negative 6, and here you get x equals negative 1 because you would subtract 6 from this one and subtract 1 from this one. So your x-intercepts would be negative 6 and at negative 1. You know that your parabola is opened up because your a is positive, so it would look about like that. If you look at that on Desmos, you can see that here is my parabola, and I had an x-intercept at negative 6, 0, and at negative 1, 0. So those are the two things that it told me. Alright, looking at the next example, would be this one. So you have two x terms, 1x squared and 1x. So I'm going to set that equal to 0 to find the x-intercepts. And then you're going to see if it has a GCF. And that one doesn't have a GCF, but a is negative. So to make it a little bit easier, we're going to take out a negative 1. Okay, and now you have to try to factor what's left. So to get a 3x, you would have an x and a 3x. Or excuse me, to get a 3x squared, you'd have a 3x and an x. And then I have to get negative 12 in this slot, but it has to add together to be 16. I'm going to multiply that by a 3 there. So try to pause it and do that by yourself. We'll try a few here. If you look at 12, maybe 4 and 2, it's negative, so positive and negative. So 3x, oh, not negative 4 and 2, sorry. Negative 2 and 6. So 3x and x is 3x squared, negative 2 and 6 is negative 12, and that would be 18x minus 2x would be 16x. So that would be your factored answer right there. Now when you get here, you have to set each piece equal to 0. So this one, and this one. You get negative 1 equals 0, 3x minus 2 equals 0, and x plus 6 equals 0. Now, negative 1 equals 0. There's no variable in there, and that's a false statement. So that just cancels out. And as we talked about, that negative only switches the sign. and it wouldn't switch the x-intercepts. It just makes the parabola more narrow or wider. Now here you would add 2 to both sides and then divide by 3. And then here you would subtract 6. So your x-intercepts would be -6, 0, and 2/3, 0. Again, we put zeros in for y's and got these 2 things out for x's. If you look at Desmos for that, I'll turn that blue one on. Oh, that's not the right function. Let me fix that. Okay, that's better. Then we've got -6 and 2/3, which is 0.667. So -6 and 2/3, that's what we found. Okay, and the last one, if you look at this, you have 2 terms. The first thing we're going to do is try to factor this. Now, if I try to factor, I set it equal to 0. Then after I set it equal to 0, then I'm going to try to factor it. It doesn't have a GCF. Multiplies to be 7, which would only be 1 and 7, and adds to be 6. Those do multiply to be 7, but do not add to be 6. So that's not factorable. So what does that mean? Well, let's look at the graph. If I look at the graph of that one, you can see that this one does indeed touch the x-axis twice, but it's not factorable. So how do we find those? And that's where the quadratic formula comes in. That's the next video. So if something's not factorable, it means one of 2 things. They're either irrational roots, or x-intercepts, or zeros, which is what you just seen. Those are irrational because they're not whole numbers. They can't be written as fractions. Or they're non-real. And we'll look at that in the next video.